Welcome back, guys. It's the last lesson for 1.4, and we've gone over the 3 different ways to solve one by factoring, which is great if you can do it, if it's factorable. 2, completing the square, which is great because you can always complete the square. It can be a little rough sometimes. And 3, the quadratic formula, which you can always do, and I don't think it's that bad. So this last part doesn't have to do with another way of solving, but instead, and remember, everything that goes up on this board, it needs to get into your notes. Instead, the discriminant, it describes the solutions, right? So since a quadratic equation is x squared, there's a potential for 2 solutions for each equation. If the discriminant here, d is equal to b squared minus 4ac. Looks familiar, huh? That's because it's the part of the quadratic equation that was inside of the square root, okay? And it tells us a lot. If, you're gonna write all this down. You need to write all this down and study it. If discriminant is positive, there are 2 real solutions. Got it? If the discriminant is negative, there are 2 imaginary solutions. Okay? Think about that. If whatever's in the square root was negative, well, we can take the square root of a negative with a real number. So the solutions have to be imaginary if the discriminant is negative, or what is in the square root is negative. If the discriminant is 0, there is 1 real solution. See, this is one of my favorite questions to ask, and I'm sad I'm not here for this right now. But why would there be only 1 solution if what's in the square root is 0? I'm gonna hang on to that question, and I wanna answer it. I want you to answer it. I'm gonna come back from this meeting this afternoon, and the first one to give me that answer will be 5-star Super Elite Club, or a badge, depending. All right, so think about it. Why, if the discriminant is 0, is there, and think about the quadratic equation, why would there only be one real solution? Okay, now, this 4th one, it kind of goes off, it's kind of different from the others. So it's either, if d is positive, there are 2 real solutions. If d is negative, there are 2 imaginary solutions. If d is 0, there's 1 solution, it's a double root. And this last one says, if d is a perfect square, well, if the discriminant is a perfect square, then the solutions are rational, meaning they're not a radical number. The radical will go away. So if d is a perfect square, the solutions are rational. The other thing I didn't write up here, but it's pretty neat to know, so you might want to write this down. I probably should write it down, but I'm out of room. If it was a regular lesson, I would have wrote it down. But if the discriminant is a perfect square, then the equation could have been factored. Sometimes, you don't know if it's factorable or not, and you don't want to complete the square, or you don't want to do quadratic formula. You can find the discriminant. If the discriminant is a perfect square, then it is factorable. What's a perfect square? 0 is a perfect square because the square root of 0 is 0. 1 is a perfect square because the square root of 1 is 1. 4 is a perfect square because the square root of 4 is 2. 9 is a perfect square. 1/4. Is 1/4 a perfect square? I think it is, because the square root of 1/4 is 1/2. So that's what makes a perfect square. All right, now let's find the discriminant and describe the solutions. Let's do a couple. Let's do 3. So with these 3 examples, we're going to find the discriminant and describe the solutions. All right, ready? So let's say we have 5x squared plus 2x minus 4 equals 0. So this is example 1. Example 2 will be x squared minus 10x plus 25 equals 0. And example 3 will be 2x squared minus x plus 1 equals 0. So when I go over the examples, I want you to focus on that I describe them. One, I'm going to describe them as real or imaginary, 2 real, 1 real, or 2 imaginary are the possibilities. I'm also going to describe them as rational or irrational, depending on whether or not it was a perfect square. All right, let's do this one here. A equals 5, B equals 2, C equals -4. And the discriminant is equal to 2 squared minus 4, I should put that 2 in parentheses. I always replace a variable with a number, put it in parentheses. All right, so 2 squared minus 4 times 5 times -4. Okay, so we have 4. 4 times 5 is 20. 20 times -4 is -80. So it equals minus -80. Okay? So this would be plus 80. So the discriminant here equals 84. So now, so the discriminant is 84, that's positive, but 84 is not a perfect square. 81 is a perfect square. The next perfect square would be 100, and 84 is somewhere in between those two. It's not a perfect square. So these are definitely going to be two real and irrational solutions. Okay? So 2 real because it's positive, and irrational because 84 is not a perfect square. All right? Let's do this one. This one's neat. A equals 1, B equals -10, C equals 25. So the discriminant D equals -10 squared minus 4 times 1 times 25. So -10 squared is 100 minus 4 times 1 times 25 is 100 equals 0. So the discriminant is equal to 0. Is 0 a perfect square? What's the square root of 0? It is 0. So there is 1, because it's 0, real solution. And since it's a perfect square, we're going to say it's rational. So this 1 real rational solution. I'm going to adjust this so we can see it, make sure we can see that. All right, let's try this one. D equals -1, no, I'm sorry, B squared, so -1, I forgot to identify A, B, and C, guys, that's what threw me up. A equals 2, B equals -1, C equals 1. So the discriminant, D, equals -1 squared minus 4 times 2 times 1. And -1 squared is 1. And 4 times 2 is, times 1 is -8. So that's equal to -7. All right, so when it comes to imaginary, guys, when the solutions are real, I do want you to describe them as rational or irrational. If they're imaginary, don't worry about it. Just say imaginary, okay? So this discriminant was negative, so I have 2 imaginary solutions. All right. All right. Well, that wraps up 1.4. Do your best, work on your math Excel. I'm gonna be back soon from this meeting, and when I get back, we're gonna answer any questions that you have, because we're gonna take a quiz on Thursday. First thing, okay? So work on that homework, and I'll answer questions when I get back from the meeting. Thank you guys so much. You have a wonderful day.